Hello. So this is a quick introduction to circulatory and respiratory system in the structures. I want to tell you the whole point of these two systems and how nutrition affects that. Actually, we will not get to nutrition today, but as you watch the video, the Ed Puzzle video that I've also posted for you, you'll see it does a really good job. In 11 minutes, it crams in a lot of information. Don't be afraid to watch that twice. I think you'll find it very interesting. Oftentimes I ask people or students, primarily at the store or anything, why do we breathe? What would you say? Why do we breathe? Most people would say, well, because we'll die if we don't. Good point. That's true. My question then is, why would we die if we stop breathing? Does everything breathe? Does everything breathe the same thing? What is it about breathing? Well, we need air, right? If we don't get air to our lungs, then we die. Why do your lungs need air? Who cares? What's in the air that you need? Well, oxygen, of course, yeah. So, if I told you from chemistry's perspective, and if you've taken chemical systems, you know this, but oxygen kills, highly explosive, which is why you're not allowed to smoke, right? If you're on one of those respirator or you have an oxygen tank with you, oxygen's pretty flammable and very electronegative. It's why we take vitamins and antioxidants, because things that act like oxygen in our body kill us slowly. So what is the magic of oxygen that it's in the air? And it's a beautiful, beautiful answer, but it's complicated. Air is really 20% oxygen. Okay, and it's just at a nice concentration such that even though there's only 20% in the air or atmosphere that we're inhaling, it's still more than what is in our body, because your body is using the oxygen. So as soon as oxygen's coming in, it is being used up. And what that means is, because there's more oxygen out here than in your body, the diffusion will go from an area of high concentration out here to an area of low concentration in your body. And so there will always be a draw of oxygen towards your body. Interestingly enough, there's even less CO2 in the atmosphere. But you know where there's a lot of CO2? In your body. So if you've ever burned trash, burned brush and leaves and such, and the smoke that's given off your vehicle, your car, out the muffler, there's a lot of waste, and that's usually carbon monoxide and carbon dioxide. Why? Because combustion, fire, gives off CO2, and we blow on it, a fire, to get the fire going, because fire requires oxygen. Oxygen is very combustible. So that's just an observation that fire, combustion, energy reactions require oxygen, and all combustion or fire reactions will give off CO2. And that's what this is. Ready? That's mostly CO2. And the plants do a good job of removing it from the atmosphere, which is in part good reason why there's so little CO2 in the atmosphere, because more things, plants, use the CO2. But all animals and mammals primarily must have oxygen. So that's the driving. So the question is, what is the pathway to where the oxygen is needed in your cells? How do we get from point A to point B? And here you are. Structures of the respiratory system. Passageway for both air and food is through the pharynx. All right, and we'll get a picture of that up. The trachea, then the windpipe. So you have your esophagus to your stomach, as we learn with digestive system, and then the trachea, the windpipe, right next to it. Goes through the larynx and then into the you can't see me, but the bronchial, which are in your chest, the main branches that go to your right and left lung. Bronchioles are smaller branches, and then the alveoli, which are, if you can imagine a cluster of grapes, that's what the alveoli look like, but they're really tiny, microscopic air sacs where gas exchange occurs. So all that air ultimately flows through there and terminates, it stops right in the alveoli. And at that point, that's where blood capillaries surrounding the grapes. If you can imagine grapes clusters in a net. So holding one of those nets, like, you know, they hold in many, like in the orange bags of oranges or other fruit. The net would be the capillaries surrounding the grapes or the alveoli where the gas is. And the gas just diffuses across the skin, the alveolar, not the real skin, but skin of the grape, or in our case, the alveolar membrane, and right into all those capillaries that are the net. And then it gets circulated all over the rest of the body. Again, you'll see this on the video I posted for you. And why would air flow into there? Well, it's pressure differences. All right, you have a small space. In a big space, it's not much air is going to flow. But if you can create a bigger space, all of a sudden, as that volume increases, air rushes in. Okay, so the flat muscle at the bottom of the chest cavity that helps with breathing. So your diaphragm opens up or drops down, creates a lot of space, and air rushes in. But that takes flexion. When the diaphragm relaxes, it closes up and pushes air out. And notice the air goes in every time the diaphragm flexes and comes out. So that's the action of breathing. It's a semi-voluntary process. You can hold your breath and freeze that diaphragm muscle for just long enough, and then your brain overrides you and allows it to relax, because nobody can flex forever, and it blows the air out. You need that constant supply. So that's an introduction here to respiratory and circulatory, because air coming in is just half of it. Now we got to circulate that. So go through these slides. Everything's pretty straightforward. Here are the things I was talking about. First, you come into your pharynx, then your larynx and your trachea, and then you have your bronchioles and your bronchial branches, and then smaller bronchioles. And you can't even see them here, but inside, at the end of these bronchioles, you have alveoli, right? And these are the grape-like clusters. And you can see the red and blue are the capillary blood vessels, which I call the net holding the fruit, you can see now. And air must come out of these alveolar sacs and into the capillary vessels, where now it is into the circulatory system. And that's what today, and well, this whole week is about, mostly circulation, but the circulatory respiratory system. It exists to circulate oxygen and nutrients. That's the whole point of the circulatory system. We eat, we swallow, we digest. There has to be capillaries in our small intestines to absorb the nutrients. We breathe. There has to be oxygen in the alveoli that get absorbed by diffusion into the capillaries. So now you have capillaries with nutrients and you have capillaries with oxygen, and those two kind of mix in your blood and then get circulated, because you're going to need fuel, and that's what those two things provide. The food is like the wood, and the oxygen is the air, of course, that's needed to make combustion in your cells occur. And that's exactly what I just said, combustion in your cells. That's metabolism. Come on, baby, light my fire. Energy. So go through these slides. I just want to give you an overall picture of how these two are interrelated. You'll eventually get to a circulatory system, because there's other health needs that are also, well, there's maintenance, I should say, health maintenance of your heart and blood. Because you need circulatory system, we don't like when the toilet clogs up. We don't like it when our sinuses clog up and we can't breathe. Any blockage in process is bad. It's going to create backup in the system, which is congestive heart failure. It's going to create backup in the system, which is going to be not a clean flow of blood through the vessels if you have plaque or arteriosclerosis, the buildup due to high cholesterol, bad cholesterol diets, and so forth. So it all relates to keeping that blood flowing, getting the nutrients and oxygen delivered to your brain and to the other parts of your body. And we don't want to affect that or influence that. But nonetheless, some of those very things that we eat are the things that help clog the vessels. Or some of these things are just inherited, like sometimes high blood pressure is just inherited. Okay. So we're going to look at, you're going to look at those and again, go through the concept. Is quite a few slides, quite a bit of writing. It's going to take you maybe a couple days. I wouldn't maybe try to understand all this in one day, but at least get the gist of it over today and Tuesday. And we'll be focusing on this. All right, white blood cells. I just saw that. So white blood cells, you want to know that they're here, but we'll talk about them more when we do the immune system in a couple weeks. Okay. So I hope that provides kind of an introduction to why we breathe. And I hope you begin to see that breathing and eating are tied together in your metabolism. And it's all about creating the energy for life, of course. So what we're focusing on is just the role of your heart and the blood vessels and circulating the air that your nose and lungs bring in. And coming to understand some of the anatomy involved in this respiratory and circulatory system. Okay. That ends my time here. Thank you for watching.